Alright, today's lesson was lesson 91. We are talking about identifying and fitting a linear function to a scatter plot. Okay, so we talked about scatter plots yesterday, right? We have that graph in the first quadrant of the coordinate plane. And now what we're going to do is notice, okay, there's sort of a trend going on here. So let's see if we can kind of approximate that trend with a line. Okay? Here I have some vocab to review. So this is just kind of basic stuff about the equation of a line. We should recognize this from previous years, or definitely the beginning of this year. But just in case, I know we forget these things sometimes, so we'll go over it. Slope-intercept form, that's when the equation looks like this, y equals mx plus b. Okay, m is the slope, b is the y-intercept. Okay, and when I say slope, remember that's what measures the steepness of a line. Okay, so how flat or steep the line is. And we calculate that by finding the change in y divided by the change in x. Okay, and in previous years, I'm sure you guys learned the phrase rise over run. Okay, so that's, again, just like saying how far are you going up or down, divided by how far you're going right or left. Okay, and we use this formula to calculate slope. Okay, y2 minus y1 over x2 minus x1. And then the y-intercept is going to be the point where the line crosses the y-axis. Okay, so again, let's just kind of summarize this down here. This is slope-intercept form, this is the slope, this is the y-intercept. And remember again, m we find using this equation. Alright. And moving on, so the steps for today's lesson, right, for the line, for a scatter plot, the best fit line. You're going to start by just identifying kind of the general trend of the data to figure out what area and direction you're going to make the best fit line. Okay, then you'll use a straight edge to draw it. You'll identify the y-intercept, identify the slope, then write an equation of the line in slope-intercept form. Okay, so once you have the y-intercept and the slope, you can write the equation of the line in slope-intercept form, like what was on the last slide. Alright, and here, sorry, the x-axis got kind of shifted here. It should be like this. Okay, so this was a graph that we looked at yesterday during the scatter plot lesson. And now we talked about how it seems that the more time someone studies, the higher their test score was. So we want to create a line of best fit for this. I see that there's only 6 data points, so I really want to make sure that my line finds kind of the center of those. So I should have about 3 above the line and 3 below the line. So this is the line that I came up with. I see that the y-intercept is right at 50. So that's going to be my B. And then the slope is, I find with this formula, remember. In order to do that, I'm going to need 2 points, right? So this is one, let's use a different color. This here is going to be 1 point, and then this is another point. Okay, so I use 2 points to find the slope. I know this point is 0, 50. And then up here I notice that this goes right through the grid at that point. So I'm going to use that as my second point. Okay, that's 3, 75. Okay, again, I'm using that point because it goes right through the 3 and the 75. It goes right through the grid right here. Whereas if we look at, say, this point down here at 1, we don't really know where that's hitting, right? It's kind of like 55, but we're not sure. So it's nice to use a point that goes right on the grid lines, okay? So with these 2 points, I'll calculate the slope. Okay, I'm just plugging them in, so I have my first point, right? 1 point and another point and the minus signs between. Okay, so just make sure they line up. You can flip them as long as you flip both of them together, okay? You have to make sure that the same point is on top and bottom. Okay, so this is the x, this is the y. This is the x, this is the y. Okay? And simplifying this, if I subtract, I get negative 25 on top, negative 3 on the bottom. So I have negative 25 over negative 3. The two negatives just cancel out, so I have a positive 25 over 3. And I have the slope, I have the y-intercept. I can make the equation of the line now. So I have y equals mx plus b. M here is 25/3 and B is 50. Okay, so just plugging those in. Okay, moving on to our next example. Make sure that you write this down if you're watching it for the first time at home. Okay, next example. This graph is showing the relationship between television size and price. So you might notice as the size increases, the price tends to increase, right? Okay, so I want to draw my line of best fit. I want to make sure I have about half and half on either side. This is the line that I thought was an accurate approximation. I notice I have 1, 2, 3 points above the line. I have 1, 2, and basically 3 points below the line. And then I have these 4 points that are kind of right on the line. It even looks like I've got 2 more on the upper side and then 2 more on kind of the lower side. So this looks like a pretty good approximation, pretty good estimate of the center here. So I'm going to look for y-intercept and a slope. I notice that the line doesn't hit my y-axis until like down here somewhere. So I need to calculate the y-intercept later. What I'm going to do first, though, is try to find the slope. So I know this point down here is 20, 0. Okay, it crosses the x-axis at 20. And I want to find another point that crosses something nicely. Okay, so it looks like this point right here is basically right through the grid. So I'll pick that as my second point. And it looks like 40, 1500. Okay, to find the slope, again, I use my equation. Then I plug in these ordered pairs. So I have 20, 0, so I'll put 20, 0. Okay, x on the bottom, y on top. Then I'll put 40 and 1500. Okay, if I subtract, I get negative 1500 over negative 20. And the two negatives cancel out, so I have 1500 over 20. At this point, I just reduce. So I know I can reduce by 10. That gives me 150 over 2, which is just 75. Okay, and then putting this in, if I were to try to make my equation, I only have the slope. So my equation is just y equals 75x plus b. I still need to figure out what b is, right? That y-intercept that we said is going to hit the axis somewhere below. Okay, so to find this, what we can do is plug in an x and a y. Okay, so an x and a y that are on that line. So I already know 2 points, these two right here, right? I could plug in either one. The easier one is probably going to be 20, 0, so I will plug that in for x and y. Okay, so here I just plugged in 20 for x and 0 for y. And solving this, I get 1500 when I multiply. So I have 0 equals 1500 plus b. Subtracting 1500 from both sides to solve for b, I get b equals negative 1500. Now I have a slope for M, and I have an intercept for B. So I can go ahead and write my equation of the line, which is y equals 75x minus 1500. Okay, since this is the slope, I can kind of tell some things about this. So this is saying if I go up 75, so if I go up $75, right, then I'll go over 1 inch. So for every inch that your screen size is bigger, according to this data, it would be $75 more. Okay, this probably isn't very accurate for TVs nowadays. They've kind of gone down in price, but for the purposes of this problem, that's what it's telling you. Okay, this line can also be helpful because let's say I want to make a TV that's 80 inches. And I'm thinking, okay, well, what should I sell it for? So I would want to know what point is that on the line. And I could solve for that exact value by plugging in 80 for x here. So whatever the inches are, I would plug that in for x. And then I would get an answer y, that's the price. I could use that maybe to estimate how much I should spend on a certain TV, or how much I should sell mine for if I have a TV that's super big. So you could also use a lower value. So say I wanted to know, what about a 70-inch TV? How much should that normally be? 70 I know should be about here. So I can estimate from the graph, but I could also find it exactly by plugging it into the equation here. Okay, and maybe in business I want to think, okay, I want to be maybe I want to sell my product a little bit cheaper than the typical market trend so that a lot of people want to buy it. So maybe then you would want to be somewhere below the line. Okay, or maybe I think my product is really great and it's worth more than the typical kind of product that they're selling. So I would want to put it above the line. Okay, I'd want to sell it for a little bit more. Alright, and moving on, so number 3, this one, and if I were to summarize this in a sentence, I might say that there doesn't appear to be a relationship between a person's age and the number of pets owned, or you could say there's no correlation. So if we're given something like this, we might say, well, there's no correlation, so there's no real line of best fit. Okay, if you look, it almost looks like a star. So I could really split this in half. I could go like this for my line, or I could go like this for my line. I could go like this for my line too, right? These all sort of split the data in two, but it's so spread out and there's no real trend, so I can't really make a line of best fit here. Right, there's just too many very different options. Okay, and this last one, this is an example that you guys had in your notes from yesterday when we were making the scatter plots. Okay, so now if we want to make a line of best fit for this, I would say probably about here be my line. I have 1, 2, 3, 4, 5 dots above, 1, 2, 3, 4, 5 dots below, and it looks like I covered some up, about 3 that are, oh well, that one I counted as above, so maybe 2 that are right on the line. Yeah. Okay, so for this line I'm approximating that the y-intercept is about 1.5. And the slope, I need to find a second point to calculate. I use this point 2, 3 as my second point. It's pretty close to being right on this intersection right here between the 2 and the 3. So I use that as my second point. Again, I just need to make sure that I stack the points so that the x goes with the y. Okay, the order though doesn't matter. I could flip this whole thing if I wanted to. Okay, when I subtract 1.5 minus 3, I get a negative 1.5. And 0 minus 2 is just negative 2, so I have negative 1.5 over negative 2. And getting rid of that negative, or since I have two of them, right, negative divided by a negative is just positive. And here, the reason I'm converting this to 3 over 4 is because I see I have a decimal and a fraction. We usually don't want to do that in math. It's kind of lazy. It's like, well, either convert it to a fraction or just divide so you have a decimal. So what I did was I multiplied the top and bottom both by 2. That gave me 3/4. Okay, so now I have this as my equation, right? Y equals 3/4 plus 1.5. Okay, but still in this equation I have a decimal and a fraction, which is just a little kind of improper, I guess. So we can write it in these other ways. I could either write both of these things as a decimal, or I could write them both as a fraction. Okay, so all three of these are all the same. Okay, they're all the same. It's just a different way of writing it. Okay, and then after that we just kind of close the activity. So again, we talked about how we learned how to fit a line to a scatter plot. We do that by first kind of identifying the general region it should be in, and then we find the y-intercept and slope. And we finally write the equation of that line. Okay, how does it fit into math? Well, it builds right off of scatter plots that we started talking about yesterday, which fit into statistics and analyzing data. I might use this in real life. Again, a ton of analysis, or if you want to project how many to sell, you can kind of use the data that you have, find a general trend line, and then you can use that line to predict and approximate. So if you have like the television example, right, the inch size influence the price, so it can tell us an idea of where we want to sell at, or what kind of size screen would be a good deal for a certain price. Okay, so we can analyze a lot from the data. Okay, and that's it for today. Your homework just has a few main problems. Each problem is broken down into different parts. So go ahead and give that a try, and I'll see you guys tomorrow. Thanks, bye.